Hey, y'all, let's finish up section 4.1. And this is starting with example 10. It was just a little bit of a long video, so I'm just going to finish up the rest of this packet, and we'll get into the next one. So using tabular form to write an equation for a linear function, this table relates the number of rats in a population to time in weeks. Use the table to write a linear equation. Okay. We have done things like this before. It's just before we use the y as opposed to the function. Okay, we're given ordered pairs. So input of 0, output of 1,000, input of 2, output of 1,080, input of 4, output of 1,160, and then input of 6, output of 1,240. And we want to know a linear equation. So there's two things we need to be able to do. We need to find the slope. So we've got f of x is equal to mx plus b. We need the slope and we need the y-intercept. Well, being that 0 is the input, our y-intercept's already 1,000. Okay, so my b is 1,000. My m is the only thing I need to find, and for that I need two ordered pairs. I'll use 0 and 1,000, because it's nice and easy. And then it doesn't matter, we'll use 4 and 1,160. All right, label my x1, y1, x2, y2. Slope is y sub 2 minus y sub 1 over x sub 2 minus x1. So y sub 2 is 1,160 minus y sub 1 is at 1,000. Divided by 4, which is x sub 2 minus x sub 1, which is 0. So that's 160 divided by 4, which is 40. All right. So our final equation is what? Just what about equation? F of x is equal to 40x plus 1,000. All right. Let's go to the next one. Let's see if I can clean this up. There we go. That's better. Graph. Okay. So for this one, I want to do something first. I actually wanted to use a different, before doing the fractional one, I wanted to show you how to do plotting points before I do the fractional format, because there's two different ways I do this. One is if I'm given a fraction, and one is if I'm not. So if I'm not given a fraction, let me just get a separate sheet of paper here. Then I use specifically 3 points when I do this. So let's say we have f of x is equal to 2x plus 1. All right. If I'm given this and I'm supposed to use points to plot this, I always use, well, it's f of x. I always use -1, 0, and 1. Why do I use 3 points? That's because if you use 2 points and you get one of them wrong, the third point will show that you're off, which I did on one of my prep things I was doing. I had totally calculated it wrong. Human error. All right, so when I use -1, I'm going to go 2 times where the x is, I'm going to put -1 and then plus 1. So that's -2 plus 1, which is -1. No, it is not. Yes, it's -1. 0, 2 times 0 plus 1 is just 1. 0 plus 1. And then 2 times 1 plus 1 is 3. So I'm just going to plot those points. -1, -1. Nope, down here, -1. Oh my gosh. 0, 1. There we go, right there. And then 1, 3. 1, 1, 2, 3. Right about there. All right. As close as I'm going to get for that one. And then label my line. Name your baby. 2x plus 1. All right. So that's how I would do it if I'm plotting it with points and there's no fraction. If there's a fraction, as there is in this case, I use different numbers. I use numbers based on the denominator. So for my x's, I'm going to use -3, 0, and 3. So f of x. All right, so I've got -2/3. Pay attention to what I'm doing here. Times -3 plus 5. The 3's cancel out, and you're left with -2 times -1, which is 2 plus 5 is 7. So our first one is -3, 7. Plugging in 0, I just get 5. So negative 2/3 times 0 plus 5 is 5. So the next order pair is 0, 5. That's my y-intercept. And then plugging in 3, negative 2/3 times 3 plus 5. Remember, this 3 is over 1. So these cancel out. And it's negative 2 plus 5, which is 3. Negative 2 plus 5. Yep. So that one is 3, 3. All right. Negative 3, 7. 1, 2, 3. And then, oh my gosh. 1, 2, 3, 4, 5, 6, 7. Positive 7. Oh, my glasses. 7. 1, 2, 3. Right there. 0, 5. And 3, 3. Okay, looks good. And then name it. Negative 2/3 x plus 5. And that is how you plot with fractions if you're plotting with points. Please learn to do this. You're not going to always be able to use your calculator, especially once you get to the next class. She will be having you taking your test, sometimes without even your calculator. So you need to get comfortable with being able to do this. Unless you're not moving on. And then you really should, but in the equation, f of x is equal to mx plus b. B is your y-intercept, and it's represented by the point 0b, at which the graph crosses the y-axis. M is your slope, and indicates the vertical displacement of rise divided by run. Recall the formula. Okay, so let me show you what we're doing here. They want us to just graph it using the y-intercept and the slope. So the first thing I do is I plot the y-intercept. Plot y-intercept. And this is the way I graph most of the time. And that's 1, 2, 3, 4, 5. I can do this faster than you can put this in your calculator. And then once I plot the y-intercept from the y-intercept, you're going to do the rise over run. And we've got negative 2/3. The negative 2 is your rise. The 3 is your run. You always, always, always run to the right. Okay. The rise depends on, it doesn't necessarily mean rise. It means your vertical change. So because it's negative, you're going to rise down. So from the y-intercept, we're going to go down 2, and then we're going to run to the right 3. 1, 2, 1, 2, 3. Plot that point, graph the line, and you are done. Besides naming your baby. Okay. So you plot your y-intercept. From the y-intercept, you do whatever the numerator is. If it's positive, you would go up. Because it's negative, we're going to go down 2. And then the 3 is in the denominator, so we're going to run to the right 3. And that's it. Graphing a function using transformation. Look at the vertical. Okay. So this is the identity function. From our toolkit functions, this is the identity function. We're going to vertically stretch and compress the graph by a factor of m and shift the graph up or down by b units. So we're just going to take a linear function, the identity function, and change it. All right, so I'm going to whip out Desmos. Let me pause the video real quick and I'll come back with Desmos. Okay, just to look at the graph, this is the identity function graph that we're looking at now, which is y equals x. It's our first one up here. If we're going to do a compression or a stretch, we've got the 1/2 x, which was the problem that we're given is 1/2 x minus 3 is the function. So if we take this identity function to see what the 1/2 does in front of the x, I'm going to show you that. That is what it does. It compresses it along or it actually stretches it along the x-axis. What if it was 2x? What if instead, if it wasn't 1/2 x and it was 2x? Just to see the difference, it's going to go the opposite direction. Okay. So I just wanted you to see that. Now, for the transformations that we're doing here, we're taking the y equals x, we're transforming it to y and with the 1/2. And then we're going to take that entire blue function and drop it down 3 places. Okay. So we're going to, it just drops down 3 because that's the, in our case of what we would normally say was the plus k. So that would be your plus k. That's your vertical shift is that -3. All right. So your stretch compression is the number in front of the x. It's going to be your A. And then the -3 is going to be your K. That's it for that one. I'm going to pause the video again and go back to the other. Okay, for example 14, we're going to match linear functions to the graph. So A, I'm looking at just the y-intercepts. A, C, and D all intercept at +3. They're all +3 for their intercepts. B is the only one that has a -3 intercept, which is down here. So 3 has to be B. 1, 2, 3. So we need to find A, C, and D. Well, A, if we start at 3 and we do the rise over run, starting at 3, this is the thing that you need to understand for the rise over run. Right now, you don't even see a run, but if I put this over 1, then you see it. So we're going to start at 3. We're going to go rise 2 and run 1. So rise 2, run 1 is right here, and this is our line. So I is A, or 1 is A. Let's look at H. +3 again, rise over run, so it'd be -2 over 1. So from the y-intercept, I'm going to rise down 2, 1, 2, and I'm going to run 1. And there we go. This is 4. So 4 is C. I understand that we already know the last one is 2, but let's just verify. We're starting at 3. We're going to rise 1 and run 2. Rise 1, run 2. There's our point, and that proves that 2 is D. All right. Moving on to the next. Oh, x-intercepts. Cool. So y-intercepts, we know to find y-intercepts, we let x equals 0 and solve for y. X-intercepts, what we're going to do is we're going to let y equal 0 and solve for x. So I'm going to write both of those. For y-intercept, because you're going to have to find both, y-intercept, you let x equal 0 and solve for y. We should just do both of those. For x-intercept, we're going to let y equal 0 and solve for x. Let's just go ahead and solve the y-intercept first. And that's where we let x equal 0. So that's f of 0 is equal to 1/2 times 0 minus 3, which is just -3. So the y-intercept is 0, -3. The x-intercept, that's y-intercept. The x-intercept, we're going to let y equal 0. So let, in this case, f of x equals 0 and solve for x. So f of x is equal to 1/2 x minus 3. Just want to see if there's anything else I wanted to do. Yes, there was. Before I do this problem, I want to show you one that doesn't have a fraction in it, just so that you understand the concept. So let me go back over here. I'm going to use the same one, the 2x plus 1 that we had. F of x is 2x plus 1. To solve for the y-intercept, we let x equal 0. 2 times 0 is 0 plus 1 is 1. So 0, 1 is the y-intercept. For f of x equal 2x plus 1, we're going to let the f of x equal 0 and solve for x. Subtract 1 from both sides. 2x is equal to -1. And then divide both sides by 2 to isolate x. X is equal to -1/2. So the x-intercept is -1/2, 0. Okay, that's how to do it without the fractions. go back to the fractional one. Okay. So we're letting y equal 0 or f of x equals 0. Here's the part that people mess up, and I want you to be very careful. In order to get rid of this 1/2, we have to multiply everything by 2. So 2 times 0, 2 times 1/2 x minus 2 times 3. 2 times 0 is 0. These reduce and gives us 1x, which is just x. And then negative 2 times 3 is negative 6. Adding 6 to both sides, we get x is equal to 6. So 6, 0 is our x-intercept. All right. Let me know what questions you have on that. But the part I have a problem with students is they do not multiply the 2 to every single one. And you have to. You can't just do it to this one and this one. You have to do it to every term. All right, horizontal and vertical lines. Lines can be horizontal or vertical, not functions, lines. A horizontal line is defined by an equation of f of x is equal to b. It just means that y equals the y-intercept. A vertical line is a line defined by an equation of x equals a constant, a. Write an equation for the horizontal line. Well, horizontal line is f of x equal to whatever the y-intercept is. And in this case, it's negative 4. There is our equation. Writing an equation for a vertical line. It's just x equals whatever the x-intercept is. And in this case, it is 7. And that's it. Determining whether lines are parallel or perpendicular. This is a lot of stuff right here. I'm going to simplify it for you right now. Please feel free to read through this. See if you can understand as far as the types of lines that we're dealing with here. I'm going to simplify as far as making sure that, well, first of all, if you multiply these two slopes and you get a -1, they're talking about perpendicular here, but I want to start talking about parallel. If we have parallel lines have the same slope. So slope for the first line is equal to the slope for the second line. All right, that's what this means right here. Perpendicular lines. They have negative reciprocal slopes. Negative reciprocal slopes. So M1 is perpendicular to M2 if M1, I'm going to give you an example. If M1 equals 3, then M2 would need to equal -1/3 in order for them to be perpendicular. Note that I took the reciprocal. This is 3/1, so it becomes 1/3. That's the reciprocal. And then we change the signs. So it's the -1/3. Gonna need to know how to do these. You're gonna have to be able to create lines with both parallel and perpendicular. It will be on the exam as well as on the final. All right, so given the functions below, identify the functions whose graphs are a pair of parallel lines and a pair of perpendicular lines. I have found that to make this easier on us, the best thing to do is just to go through and say, okay, well, Fm is equal to 2. G's M is equal to 1/2. Just the number in front of the coefficient of x, the number in front of x. H, the M is -2. And J, M is equal to 2. So parallel lines, they have to be the same slope. F and J are parallel. Perpendicular, negative reciprocal. So if we've got 1/2, the other one should be -2, which are G and H. Okay. Write an equation of a line parallel. We're going to do both parallel. Oh, well, the next one we'll do perpendicular, I think. Oh, yeah. So let's just do one. We need a line parallel to the given line. So the first thing we need to know here is, okay, all I need to know about this line is what's the slope. The slope is 3. So that means the slope for my new line that I'm creating is going to be 3. And the point that it's passing through is 3, 0. All right. We can use the point slope formula on this, or we can use the y equals mx plus b. Totally your call. I find most of you like to do the y equals mx plus b. This is x and this is y. So 0 is equal to m is 3 times 3. We're looking for b plus b. 0 is equal to 9 plus b. Subtract 9 from both sides, and b equals -9. So f of x is equal to the slope, x minus 9. Let me know what questions you have about that. Find the equation of a perpendicular line. So in this case, we just need to find the slope of the original line, which is 3. The slope of our new line, is going to be the negative. So this is positive, so it's going to be negative. And then this is 3 over 1, so it needs to be 1/3. All right. Again, I can use the y equals mx plus b. And y is 0 again. Slope is -1/3. X is 3. Oh, they made this nice on us. And then plus b. Again, we're looking for our y-intercept. Well, these two reduce because this is over 1. 0 equals -1 plus b. Add 1 to both sides. B is equal to 1. So f of x is the original, the new slope, -1/3, x plus 1. And that is it for that one. We've got one more. Finding the equation of a line perpendicular to a given line passing through a point. Okay. Yet again, you're going to want to need to know this for your exam as well as the final. If we are only dealing with points, we have to deal with, we've got an original line that passes through these points. I need to know the slope between those 2 points in order to create my perpendicular line. So -2, 6, and 4, 5. x1, y1, x2, y2. I'm going to use m equals y2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 5 minus y sub 1 is 6 divided by x sub 2 is 4 minus x sub 1 is -2. And that is -1 divided by 4 plus 2 is 6. So -1/6 is my slope from the original line. But we want a perpendicular line. So therefore I need to take this and make it perpendicular. So it has to be the new slope, has to be negative this, which is already negative, so it's going to be positive. And then instead of 1/6, it's going to be 6 over 1, which is just 6. Sweet. All right, and they want the new line to go through the point 4, 5. Y is 5. The slope is 6. X is 4 plus b. 5 is equal to 24 plus b. Subtract 24 from both sides. We get -19 is equal to b. So the new function is 6x minus 19. For those of you who prefer the point slope formula, I'm going to do this real quick for you. Y minus y sub 1 is equal to m x minus x sub 1. What we do is we just use the new point, 4, 5, that they're giving us. And we're using the new slope, 6. This is x sub 1 and y sub 1. Y minus 5 is equal to 6 times x minus 4. Distribute your 6. Y minus 5 is equal to 6x minus 24. Don't forget to distribute to that -4, and then add 5 to both sides. Y equals 6x minus 19. Just make sure and change the y to an f of x or any kind of function. 6x minus 19. And that's it. Either one works. That is 4.1. I'll see you on 4.2. Let me know what questions you have.